You should fix one here and can't do that. Take this propulsion system. My son developed that at NASA. He was a lead engineer on it.
Round and round it goes. 2 payload, 1 in the belly, 1 in the nose. So the package delivery people like that. The commercial people like the nose. You put in camera, sensor, whatever. And I got to show you this part because it's so cool.
You said this is a hybrid?
Yes.
Okay.
It is. It is. 3D printed part.
Oh,
You
yes,
could,
absolutely.
okay? 3D printed part.
Yep.
Okay. Camera, turret.
Yep.
And we can put whatever you want inside.
So long as it doesn't fall off the camera turret.
That's right. Well, no. You'll have platforms specifically made. So
Oh, attach
that'll
like
work.
attach points?
Yes. We'll have, depending on the sensor you need, we'll put these platforms in to secure the sensor that you individually require.
Yeah.
So we're the aircraft manufacturer.
And it would just tie into other electronics through
Yep. Exactly. See, this is a connection here.
Okay. There would be like, this probably goes to the receiver that your remote control
Exactly.
ties into? Okay.
Exactly.
And how big's the gas engine in back there?
It's approximately 4 horsepower.
Oh, wow.
4 horsepower.
And it just drives a generator?
Yeah.
An electric generator?
Yes, it
And
does.
it runs the motors then?
Exactly. So with a 4-pound payload, we can stay aloft for 2 hours.
Huh.
Okay? If you want to put nothing but fuel in it, it'll go in a straight line 120 nautical miles.
Wow.
This is huge. It is game changing.
How much fuel does this hold?
A lot. You can have, they're 2 separate tanks.
Okay.
But like I said, it'll be enough fuel for 3.5 hours of flight. If you don't want to carry anything, don't imagine why you would want to.
That'll maximize your range.
Yeah, exactly.
Or 120 mile distance.
Yep, exactly.
Wow.
It is.
So you're NASA, is that? No, you're Advanced Aircraft Company, but I see a NASA sign.
Yes, because my son used to work for NASA at the Langley Research Center. He was the lead engineer on this.
Yeah, I just saw
Big
that
flight.
next door, I think. And
Yep.
talked to them about that.
All right. So the research done on this prototype was to demonstrate that in fact you can make a transition from horizontal to vertical flight and not crashing.
Oh,
Okay? Because it had never been done before.
okay.
Okay, so this video documents the transition. They put willies on the wings so you could see all the turbulence, and it landed. Bill then decided a year ago, I want to commercialize this. I want to make money doing this. So he had to quit NASA. He negotiated a license with NASA to do just that.
Oh,
Now, this prototype was battery powered.
right.
It was, kind of shoestring. How do we demonstrate this and then go to the next step? Well, NASA being NASA, that was nice. We don't want to do this. We have another project. Bill goes, no. I want to do this project. This has legs. So he quit. He developed HAMR, the Hybrid Advanced Multi-Rotor, because the propulsion system is the magic sauce in this one.
The hybrid system.
Yes. When this one gets solid, and we have it, because this is prototype number 5.
I see, okay.
All right? When this is solid, that propulsion system is going there. And then all of a sudden, we've got 24-hour endurance on this. You see what I'm saying?
So the system will go back to NASA for work?
No, it becomes private. NASA
Okay.
will collect a royalty.
And you guys
they're
will build a system like this, a VTOL system,
Yep.
using this hybrid
Right.
power system.
Right. That's the plan. Now, in fact, it's not next week and it's not tomorrow.
As long as it takes.
It's as
You're
long
gonna
as
stick with it.
takes.
Will the goal be to lift a human and transport a human, or
We have
packages,
the license.
or
We have the license. The NASA license says we can go up to as large as a 4-person vehicle.
so that's probably the goal then, is to move people.
No, actually,
Or-
no, it's not.
Okay.
No, it's not. That's not the goal. The goal is actually to appeal to as wide a person.
To do whatever.
Yeah. There's going to be a lot of integration problems with personal air vehicles that people with a lot more money have. Uber Elevate comes to mind, okay? Because they're tackling the infrastructure. They're not.
So you're talking about integrating with like the airspace system,
Yeah.
and traveling
We
in
don't
the
wanna do
country
that.
or
We don't
whatever.
wanna do that.
I see.
We want to be like Boeing is to American Airlines. We want to be the
I see.
aircraft manufacturer to the drone service provider, whether they're building yellow personal air vehicle taxis or we want to build the aircraft.
And those people can work with the FAA to figure out the regulations.
We'll be the biggest cheerleaders.
where they can fly.
Yeah, we'll buy the booths at their industry trade shows, but no,
Gotcha.
we don't want to do that.
This
We're
is
not good
much
at it.
more cool to work with than
Well,
regulations.
for a guy who's an engineer, you betcha.
Right.
You betcha.
I
So,
missed the part about the hybrid system. What is that?
okay, the hybrid system is a 2-stroke gas engine. Okay? It takes regular gas, 40 to 1, cut with oil.
Like your lawnmower.
Yeah.
Or like
it's a
your,
weed
like your
whacker
chainsaw,
engine.
right.
It's a weed whacker engine, okay? That turns the generator in the back, that's a little circle, all right? Has the raw power, goes through the rectifier, which I'm hitting just the tops of the waves because I'm not an engineer, but then it distributes the power out to these AC motors. It's liquid cooled. How cool. Because air cooling didn't work.
Did you say these are AC motors?
I believe so.
Because drones, for example, would typically use DC, wouldn't they, or not? Or am I wrong?
I'm not the proper person
sure.
to answer that question. My understanding was these are AC brushless motors.
Okay, maybe I just don't know what I'm
Okay.
talking about there.
Yeah, I don't either. But this is the secret sauce. I mean,
This is a hybrid.
yeah.
You can see on the back gas engine, see the exhaust pipes? Takes just a gas oil mix like a lawnmower.
Yep.
Powers the generator, powers the motors.
Yep.
It's really cool.
It is. It's something.
And you said your son
Yeah.
is the brain behind it.
Oh, yeah.
He was the NASA engineer
Exactly.
that helped develop this.
Exactly. He thought he was going to be don't record this. He thought he was going to be a great auto mechanic. He surprised us all.
Applications, non-military applications.
He's a very, very high-level mechanic.
He is. He is.
Right.
He can do anything. I mean, it's just. So, what's your connection?
Well, I'm a software developer, but I just love aviation. So I'm just here because I love airplanes.
Yes, and you can see what software can do.
And he actually really likes electric-powered vehicles. He has an electric car
Oh.
and really enjoys this electric stuff.
Oh yeah, that's right. Definitely. Well, I think honestly it is the future. Combustion engines and so forth run on they're nothing at 60-65%. This is the way to go. So the question is, how do you get there with the most infrastructure available today? Today is gasoline. Stores a lot of energy and then can change it to usable power. It's number 5. It's number 5. It's just about ready to go to commercialization. We're working up. So that's this plane doing its
So this pivot here is for yaw control.
The thing that
and there's one on the other side as well. And the other ones, they use differential power for pitch and roll.
Just have to be patient. That's why he's aiming for
Somebody's got to